Hello everybody, and welcome to my Rust tutorial. I have created this whole software program for the purpose of demonstrating various aspects of programming as they are um, executed within Rust, including but not limited to variables, loops, conditions, expressions, or conditionals, expressions, and functions. Right off the bat, you'll probably notice that I have a whole bunch of .exe files over here in my folder. And that is primarily because in order to get Rust to work, you have to download and install um, this thing called Rust Up, which allows you first and foremost to program and compile and debug and etc. in Rust. So this right here is basically everything that was included within Rust Up. Um, in addition, I understand that cargo, as many of these are named right here, is a very important component of programming in Rust because of its functionalities in creating directories and manipulating files, all of which so that your machine can recognize them as Rust. But I was able to do this whole thing just manually creating the files and stuff myself in File Explorer. And I imagine I could probably get away with this right now since this is a smaller software that's a bit more basic, but I imagine larger ones in more professional settings would most likely require the use of cargo. So, anyways, uh, first of all, let's run this thing. And to do that, we're going to pull up my terminal and we're going to type in period that was backspace, period backslash rust c, and then the name of the file, which is module05. That's not an M. module05.rs. Hit enter. Now you'll notice that two new files were created over here, module05.exe and module05.pdb. This basically means that it worked. The built-in debugger for Rust did not recognize any problems with the code, and they were able to compile them into executable formats, which is what this .exe file is. And we are now going to actually run that using period backslash module 05.exe and hit enter. All right, so it just ran my entire code basically, and now let's walk through this and explain what exactly happened in the code which led to each of these outputs. So first and foremost here, I basically separated my code into different functions to explain the various aspects within Rust that are all called down here in the main function. The more I was using Rust, the more similarities I drew between it and several of the C language variants like C++ and C sharp. And this use of functions with one main function to tie it all together was certainly one of the bigger ones. So, so over here in my variables and expressions function, I have passed in as parameters functions that I've chose to rename as x, y, and z, which I declared in main over here, 10i, 64, and 3.14, with the values assigned to them respectively. Now, one very unique aspect of variables within Rust is that variables are separated or categorized as either mutable or immutable. By default, they're immutable, and what that basically means is that the values assigned to them you can't change them, they're meant to remain static. In fact, if I were to try and alter the value that was assigned to my variable x, the program would just error out. And as you can see, the value was able to be successfully passed in because according to this print statement telling me to print out the value of x, I was able to get that value, 10. Now, in the meantime, mutable variables are exactly not that. They are variables whose values can be changed and can be altered and messed with. As is the case down here, I print out the initial value of y, 64, and then I added x's value to it in this statement, which changes y's value to be that of itself plus x. So now y is 74. So now down here, I have z as yet another mutable variable. And this one, instead of being an integer, I have assigned as a floating point. You may have also noticed up here these little funny things right here, where after declaring the parameter name, I have colon and then this weird combination of numbers and letters. Now that's basically the equivalent of the data type declaration that Rust uses. So while other programs might use statements like int or char or float, Rust instead uses these. And what they mean exactly, I'll explain right now. So integer variables can be assigned as either i32 or u32. Or really, the number is actually how much data in bits they're required to take up. So you could also set them as i8 or i16 or whatever else. But for my purpose here, I have assigned them as i32. Now, they can be either i32 or u32, and what that means is they are either signed or unsigned, respectively. If they're unsigned, then that means that they could be, or no, if they're signed, that means they could be either positive or negative, and thus require the sign to distinguish between the two, hence why it's signed. By default, they are unsigned and thus always positive, but for the sake of demonstration, I have chosen to declare x and y as signed variables. And then over here with z, I have chosen f64, because f is what you would have to declare if you wanted it to be a floating point variable, as 3.14 is. And just like with the mutable variable y, I am able to manipulate this too. Start off as 3.14, subtract 0.14, and now it's just 3. Sorry about that, I'm recovering from a sickness. Anyways, now I'm going to demonstrate the use of conditionals, and thankfully, or no, not conditionals, expressions. And thankfully, Rust is capable of most of the same mathematical expressions that other languages are capable of. So over here, I just did subtraction, and up here is addition. But then I've also done multiplication and even modulo. That's pretty cool that it's even capable of modulo. Now, interesting little thing I noticed here, in most other languages, whenever you're doing math with floating point variables, the output will usually result in a 0.0 or some decimal at the end of it, even if it's a whole number in the output. Now, with Rust, those roles are actually reversed. Up here, I've had to specifically write out a number that was, or that had a decimal point in it, so that the program could recognize it as a floating point variable and thus make it work mathematically alongside another floating point variable. However, the output, if it's a whole number, is just the whole number itself. Very, very fascinating. Very interesting. So now we're going to move on to these two little loops that I created. Just like other programming languages, Rust is very, very similar, although it does have a number of very interesting and unique traits when it comes to loops. So with conditionals, once again, it has like the same idea of if, else if, and else, just like in C and its variants. As you can see demonstrated here, But when it comes to loops, things are particularly interesting. So first of all, down in the main, I've called the conditionals and loops function and passed into it 2 and 10u. Now, you may have noticed that I have two different variables here with essentially the same value assigned to it. And that's because, as I was talking about near the beginning, one is signed and the other is unsigned. Now, Rust has a number of very strange internal rules that dictate what you can use certain data types for. And apparently there are some things that Rust will only allow you to use unsigned variables with that you can't use signed variables with. And this is one of those times because I've tried to use the unsigned version instead, but it just wouldn't work. I had to change it to the unsigned version. Did I say I tried to use the signed version? Well, either way, I tried to use the signed version originally, but instead used the unsigned version. Or instead had to use unsigned. So let's look at this first loop. Right here I have loop written out, and then another pair of square brackets as if it were another function. So it's going to essentially loop itself through this over and over again. And just like before, I have thankfully set the value as mutable, so I can alter this value and make it go up by multiplying it by 2 every single time. I've also added a number of if statements that, will trigger various fun little things under certain conditions. So down here, you'll notice I have beginning of a loop and then 2, 4, and 8 written out here. Now over here, you'll notice this print statement is written like print instead of println. And I learned this back when I was creating a similar piece of software in C#, but this is essentially the program's way of saying print, but on the same line rather than on a new line, which is what println would mean. So because of that, every single time it loops itself, I am able to have it print 2, 4, 8 on the same line. Once I got to 8, I have this little thing right here, which then prints out right here, hey look, the minimum bit size, which of course is 8. Going up, I then have another one, hey look, the bit technology used for my favorite classic gaming console. For those of you who don't know, that would be the Nintendo 64. Love that, lots of good games on it. And then I have it set to if value is greater than or equal to 512, just in case, something happens and it happens to exceed this value, then I could essentially stop it right here by printing out this statement and then having this keyword break, which causes the loop to be broken out. So, in that way, I suppose Rust kind of sort of just negates the need for while or do while loops because at any point you can just type in break and then, that will be the end of it. But of course, it would be best to have break inside of a conditional statement like this so that, it can actually function as a loop where it will continue to loop until this condition is met and then it will break. So now I'm going to present a second loop and we're essentially going to do the same as before, but now I'm going to utilize this function right here, which was built into Rust, and it's essentially how Rust does exponents. I did mention that Rust was capable of most of the mathematical expressions that other languages are capable of, but exponents are one of the ones that it isn't by default, at least not in, the same way you would think. So instead, what you have to do is essentially take the value and then put .pow, short for power of, and then in the parentheses select what you want your exponent to be. So for this, I have created another variable exponent and passed it into here according to the main. The program is, or let's see, exponent Okay, so according to main, it looks like exponent is 10. Um, oh, yes. Yes, it is 10 because that's the exponent that we want to start off with. In the previous loop, it basically went up until you got to what was basically 2 to the power of 9, which is 512. And so for this to work, I've had to make exponent start off as 10 so that I could start at, the next number in the sequence, which results in 1024. So now, just like last time, since exponent is mutable, I can alter it and then have it add 1 to itself every single time it loops. And then, once the exponent reaches 2 or is greater than 20, that is when this program will break. Interestingly enough, when I was constructing this, I noticed that Rust is actually built to be smart enough to recognize when a stack overflow is occurring and then use that as essentially its means of aborting the system. So I noticed that when I was uh, outputting numbers that were bigger than this one, what is that? 1,048,576. Any numbers that had like more digits than this one, some amount more, it would just be a stack overflow and it would crash. And the reason for that is because the variable is the variable is assigned as U32, meaning it's 32 bits, and it can only take up 32 bits of space. So this time around, I have definitely had to cause it to stop the moment it reaches, or the moment the exponent reaches 20, because any bigger than this, and well, I probably would destroy this computer, or at the very least, this program's potential of functioning properly. Supposedly, there is talk of an unsafe form of Rust if you want to, give yourself more freedom at the cost of additional risk, of course, but I hear that is pretty advanced, so it will not be covered here. And then, as explained before, down here we have main, where I've basically declared all the necessary variables I want to use and then pass them into each function. And then down here, I just have this thing to designate that the program is over. So the program is over. Thank you very much for watching, and I hope you all have a good day.